Welcome back. Cold fronts. And again, if you're doing this in the book, you can find the page right there. That wasn't it, but you'll see it. Um, what we got to look at with this one is what does it look like from the side as a cold front moved in? Now, this is hard to see from like a one human perspective. This would be like if I could look out the window and see a broad area, but I need to be able to see like with superhuman sight. Have to be able to see a very large area, which isn't impossible from some vantages. If you have the right angle and the right elevation to be able to see over a large area, what would it look like as cold air moves into town? Now, depending on when you're doing this, if it's right around these dates right here, around the 12th, we're in the middle of a week where we've had cold air come to town, and then it's gotten kicked out by warmer air, and by warmer air I mean it's like 30. That certainly doesn't I know feel like a warm day, but compared to what it was last week when it was like 2, it's warmer, right? And then cold air is going to come back after this. We're seeing cold air masses move in and warm air masses move in. So what does it look like as that happens? So I drew a big line here, and I'm going to label below that just like it's the ground, it's the earth. Excuse me. On top of the earth, again, if I could like look side view. So what I generally do when I'm teaching this is I say, let's draw some houses. And I'm going to draw these so ridiculously large, out of scale, that it doesn't make any sense. And if you say, but Mr. F, you're drawing those tiny, that's the idea. There's a house, there's a tree, there's like a barn, and I don't know, a silo next to the barn, right? And those are way too big. So I'm saying it's got to be on a very small scale, but that's to help us see the idea that we're looking sideways at the atmosphere. What does it look like as cold air comes to town? Now, since we're all experts in our air masses, and if you're not, you got to go back and work the lesson called air masses, where you saw that reference table right there, air masses. That was one of the lessons we did. It's not terribly difficult, honestly, but it'll be completely foreign. And if you've never seen it before, it's going to be like, what is this guy writing? Because what I'm going to write is a little c and a big P. That's the kind of air that's coming to town for us here in central New York when cold air moves in. Continental, polar. And again, if you know your air masses, you're going to know what that means. Continental means it comes from a continent. It's going to be dry. Polar means it comes from a polar region. It's going to be cold. So, what does it look like across Earth's surface as this colder, drier air moves into town relative to what would be warmer, wetter air on the other side of it? And again, if you know your air masses, little m, big T, maritime, tropical. Well, here's what it looks like. Cold air, a couple things we got to know. Go way back to density. Cold air is more dense than warm air. So when it comes in, it can't go up above the warm air as it shoves it out of the way. It's got to be more dense and it's got to jam its way underneath. And in a fairly violent set of circumstances, this cold air, whoop, that's bad. Let's try that again. This cold air jams its way underneath the warmer air because it's cooler, because it's more dense, because cold air is more dense than warm air. Like driving a car through our atmosphere, the air that you drive through has got nowhere to go but up. And here we go again with the whole air rises thing. Now, I don't want to necessarily write that whole entire thing, nor do you, on every single one of these little cheat sheets, because, like we said in that last lesson before this cheat sheets, air rises, expands and cools, hits the dew point, condensation occurs. The relative humidity is 100%. The air is saturated and clouds form. You feel free to write all that every single time we do this. But maybe what we can do on the notes is like, no, I'm not saying you don't have to know that stuff. You do, but let's shortcut it and just say, we've already learned, Mr. F has already ingrained in us, jammed into our heads, the idea that air rises, all that stuff happens, and clouds form. In fact, we're going to go ahead and draw the cloud. Do the best you can with this. I'm not saying this is easy. The clouds that form in these circumstances, we call Anvil Clouds for short. They have this kind of shape. Not bad. Try it to the best of your ability. Anvil being like those things that blacksmiths use, those things that the Looney Tunes are dropping on each other all the time. Um, the real name for them tends not to come up on the Regents a ton, but I guess we got the time. Let's write cumulonimbus right in there. That's the technical name of this kind of cloud. All right, some important things that I want to make sure we get down about cold fronts. Thing number one, cold fronts move quickly. Compared to warm fronts, as these things sweep through, they tend to go pretty fast. Cold fronts, because of this like blunt edge, as it like snow plows its way underneath warm air, makes the air rises quickly. Makes the air rise quickly. Air rises quickly as cold fronts come plowing their way through, and as a result, we get very tall clouds. Now, this is like a textbook example of how it works. Generally, in summer, it's not. This isn't going to happen this week. We're not going to get a big, tall thunderstorm cloud because this warm, wet air we're in is not warm and wet enough to produce that much energy. Go to summertime when very cold, dry air is meeting very warm, wet air. This is the story. Okay. What you're going to get with these is quick, violent storms. Things like thunderstorms, hail. This can lead to tornadoes. But let's note one thing actually, and that is about where they happen. The storms themselves, the rain that's going to happen, it's like this happens all so quickly. The air rises quickly, and boom, it dumps its moisture right back down on the front. So you're going to see how that's different. That might be hard to picture right now. The storms, I'll say precipitation on fronts. You'll see how the worm fronts are different in a few minutes when you do that next guide, the worm front one. But here, it's like the air rises. All the up and down in here is what creates the friction necessary for lightning and thunder, and it just dumps its moisture right back on there. So this summer, try to note this. You're going to see a thunderstorm at some point this summer. You're going to be in warmer, wetter air. This cold air is going to come rushing through. The winds are going to go berserk for a little bit and be shifting directions. The air is going to be, the rain's going to dump on you quickly. Go inside because there's probably thunder and lightning. But then the whole thing moves on. And then when it's past you, you're going to be back into clear air and hopefully a little cooler and less humid. These can be a relief on those hot, humid days, even if you got to deal with a little thunder and lightning. Okay? There you go. That's cold fronts. We're going to look in contrast how warm fronts. There's a lot of things that are similar. It's still less dense air rising, the warm air. It's still when air rises, it expands and cools and forms clouds. But there's a couple of things that are subtly different. Let's check it out in the next video. Everybody, see you in a sec.